The mystery that refuses to die. What if your thought, your awareness, your very sense of being isn't just something trapped inside your skull, but something woven into the very fabric of reality itself? What if consciousness isn't an accident of biology, but a field, a present, a phenomenon as fundamental as space, time, or gravity? From the dawn of human reflection, this has been the question that refuses to die. Philosophers, mystics, neuroscientists, and physicists have all approached it, each armed with their tools of reasoning, observation, and imagination. And yet, despite centuries of effort, consciousness remains the enigma at the heart of existence. The fact that we are aware at all. Science has unraveled galaxies, split atoms, mapped the genome, and built machines that think in their own uncanny ways. But in all this progress, there lingers one quiet, unsettling truth. We do not know how subjective experience arises. We do not know why the firing of neurons gives rise to the redness of a rose, the taste of chocolate, or the ache of longing. This hard problem of consciousness, as philosopher David Chalmers called it, stands as one of the greatest scientific and philosophical puzzles of our age. The traditional view, rooted in neuroscience, insists that consciousness is emergent. The brain, with its 86 billion neurons and trillions of synaptic connections, creates mind the way a river creates waves. According to this model, when the brain stops, awareness vanishes. We are but biological machines, consciousness a byproduct of complexity, destined to flicker out at death. But there is another possibility, a possibility that refuses to go away, no matter how much reductionist science tries to dismiss it. What if consciousness is not produced by the brain at all? What if the brain is less a generator of awareness and more like a receiver, a filter, or a translator of something much deeper? What if consciousness itself is fundamental, the ground of being, the invisible canvas upon which the universe paints itself? This tension between two paradigms, consciousness as an emergent property of matter versus consciousness as a fundamental feature of reality, has animated debates for centuries. It is a tension that stretches from Descartes' thinking self to modern neuroscience labs, from the Vedantic sages of India to the quantum physicists of the 20th century. And it is this tension that sets the stage for our journey, because behind the abstractions and the theories lies something very personal. You, me, the first-person reality of awareness that refuses to be reduced to equations or brain scan. Consciousness is not a theory to us. It is the one thing we cannot doubt. Descartes famously said, "I think, therefore I am." But even more primal is this: we are aware, and that awareness is undeniable. Consider this: every scientific measurement, every philosophical reflection, every observation of the world arises through consciousness. It is the one thing that cannot be bracketed out, the one lens through which everything else must pass, and yet it remains the least understood phenomenon of all. How can it be that the very medium of knowing is itself unknown? This paradox haunts both philosophy and science. In neuroscience, researchers probe deeper into the electrical storms of the brain, mapping which regions light up when we dream, remember, or meditate. In physics, others ask whether the act of observation in quantum mechanics hints at some deeper link between consciousness and reality itself. Neither field has yielded a final answer. Instead, each advance seems only to magnify the mystery, and so the questions multiply. Is consciousness merely an emergent illusion, a clever trick of neurons fooling themselves into thinking they exist? Or is consciousness the one true reality, with matter and energy arising as expressions within it? Could it be that we have mistaken the shadow for the light, assuming the brain produces what it may only transmit? Some thinkers argue that even framing the problem this way misses the point. They claim that consciousness is not something that needs to be explained in terms of something else, it simply is, just as physics once had to accept space, time, and mass as primitives. Perhaps we must accept consciousness as a given, a fundamental aspect of the cosmos. If so, then our scientific maps are incomplete, leaving out the very phenomenon that makes mapping possible in the first place. Others push back, warning against romantic speculation. They argue that to posit consciousness as fundamental is to abandon the hard work of science for metaphysical comfort. Better, they say, to continue dissecting the brain, simulating its pattern, and waiting for the fog to lift. After all, every year neuroscience makes strides decoding dreams, manipulating memories, even engineering brain-computer interfaces that blur the line between mind and machine. Surely, they argue, the key will be found in the circuits of the brain, and yet the mystery refuses to go away. For every promising experiment, the hard problem still looms. Why should physical processes give rise to inner experience at all? Why should there be something it is like to be you watching this screen, hearing these words in your mind's ear, pondering their meaning? Why should matter wake up? This is where quantum physics enters the stage, not as a solution, but as a provocation. The quantum world is notoriously strange. Particles that behave like waves, entangled partners that influence each other across cosmic distances, events that remain indeterminate until observed. Some scientists have wondered, does consciousness play a role here? Is the observer not just a passive witness but an active participant in reality itself? To be clear, these ideas are controversial, often dismissed by mainstream physicists as speculative at best, mystical at worst. Yet the allure remains, because if quantum mechanics already forces us to rethink the nature of matter, time, and causality, why not consciousness too? Perhaps the two mysteries, the quantum enigma and the riddle of mind, are entangled in ways we have only begun to imagine. And so we arrive at the threshold of a grand journey, to trace the contours of this debate, to explore the crossroads where neuroscience, philosophy, and physics meet, and to peer into the speculative horizons where consciousness may not merely inhabit the universe, but help shape it. What lies ahead is not a set of final answers, but a map of possibilities. We will move through the terrain of science and speculation, skepticism and wonder, charting how thinkers across ages and disciplines have wrestled with the one fact that none of us can deny: we are aware. And until we understand that awareness, the deepest mystery of all, will remain unsolved. So let us begin with the question that launched our journey. Is consciousness merely a flicker of the brain? Or is it the hidden field we have not yet mapped, the unseen dimension through which reality itself comes alive? The scientific foundations of consciousness studies, to truly explore whether consciousness might be something more than the brain, we first need to stand firmly on the ground of what science already knows and what it does not. The mystery may tempt us towards speculation, but before stepping into the unknown, we must honor the methods that have carried humanity from superstition into understanding: careful observation, empirical testing, and the relentless pursuit of evidence. For centuries, the dominant worldview in science has been materialism, the belief that reality is composed entirely of matter and energy, governed by physical laws. Within this framework, consciousness is viewed as a byproduct of physical processes. Just as fire produces heat or engines produce sound, the brain, by its sheer complexity, is said to produce consciousness. No ghosts in the machine, no hidden field, simply neurons firing in patterns so intricate that awareness emerged. This idea gained its foothold in the 19th century, as biology and physics began to explain phenomena once attributed to the soul or the divine. The discovery that brain injuries could alter personality and perception was especially influential. When Phineas Gage survived a railroad accident that sent an iron rod through his skull, his transformation from responsible foreman to impulsive drifter shocked observers. Consciousness, it seemed, could be reshaped by brute damage to tissue. The mind was no ethereal essence, it was bound to the brain. Fast forward to the modern era, and neuroscience has transformed this intuition into a vast research program. Scientists speak of the neural correlates of consciousness, the specific brain, states that align with particular conscious experiences. Electroencephalography maps the rhythms of brain waves. Functional MRI scans reveal which regions light up, when we recognize a face or imagine a scene. With each technological leap, researchers aim to chart the landscape of awareness, one neural circuit at a time. One influential model is the global workspace theory, proposed by cognitive scientist Bernard Baars and later developed by Stanislas Dehaene. Imagine the brain as a theater. Countless unconscious processes, perception, memory, motor control, compete for attention backstage. But only when information reaches the bright spotlight of the stage, the global workspace does it enter consciousness. In this view, awareness is the brain's way of broadcasting select information widely, integrating it so that decision-making and planning can occur. Another prominent contender is integrated information theory, IIT, pioneered by neuroscientist Giulio Tononi. IIT begins not with brain anatomy, but with the nature of consciousness itself. Every experience, Tononi argues, is both highly integrated, a unified whole, and highly differentiated, rich in detail. The theory attempts to capture this mathematically through a measure called phi, a number representing how much information a system integrates. A system with high phi, like a human brain, has rich consciousness. A system with low phi, like a simple circuit, has little or none. These models differ in approach, one metaphorical, one mathematical, but both share the mainstream conviction: consciousness is generated by the brain. They seek to explain how the orchestra of neurons gives rise to the symphony of mind, and to a degree they succeed. Studies show that when patients lose consciousness under anesthesia, activity in the global workspace collapses. Experiment. Manipulating brain networks demonstrate changes in phi that align with degrees of awareness. Step by step, the science grows more precise. Yet, even as neuroscience builds these elegant maps, a shadow lingers, the so-called hard problem of consciousness. Coined by philosopher David Chalmers, the hard problem asks, why does all this processing feel like anything at all? Why should billions of electrochemical signals produce the taste of strawberries, the color blue, the pang of nostalgia? Why should there be an inner movie accompanying the brain's mechanics? The easy problem, how the brain processes vision, how it coordinates movement, how it stores memories, are challenging but tractable. They can be answered by examining functions, circuits, and computations. But the hard problem resists. No matter how detailed our neural maps become, they do not bridge the leap from physical processes to subjective experience. It is like describing every part of a piano and its strings, yet still being unable to explain why music feels the way it does when heard. This is not to say science is blind to the challenge. Many researchers acknowledge the gap, while some argue the term hard problem itself is misleading. They suggest that consciousness may dissolve into the easy problems once we understand the brain's mechanics more fully. Others disagree, warning that the subjective quality of experience is not something that can be reduced to function. For them, no matter how much we map the correlates, the essence of awareness will remain untouched. Materialism, nonetheless, holds the commanding position. Its explanatory power is immense. Consider the revolution of brain-computer interfacing. Electrodes implanted in paralyzed patients have enabled them to move robotic arms with mere thought. Such feats seem to confirm that the brain's patterns are consciousness in action. Similarly, the use of transcranial magnetic stimulation can induce or disrupt experiences, causing flashes of light, altering moods, even temporarily silencing speech. These interventions reveal a clear causal link between neural machinery and conscious states. But notice the contrast. While we can manipulate and measure consciousness, the qualitative mystery remains. We can cause someone to see light, but we cannot explain why light is experienced as luminous. We can silence speech, but we cannot explain why the silence feels empty. In other words, we have mapped the shadows, but not the source of the light. This tension fuels ongoing debates between reductionists and those who believe something more fundamental may be at play. Reductionists argue that every advance brings us closer to dissolving the mystery. Just as life was once considered inexplicable until DNA and biochemistry provided the key, so too will consciousness eventually yield to neuroscience. To them, The hard problem is a temporary placeholder for ignorant. The other side insists that the analogy fails. Life's processes were explained without addressing subjective feeling. Consciousness is unique in being defined by subjectivity itself. To treat it as merely another puzzle risks ignoring its essence. Chalmers himself has suggested that we may need a radical expansion of science, perhaps even a new fundamental law, to account for experience. And here is where the foundations begin to crack, or perhaps to open new doors. If our best models cannot explain why consciousness exists, what does that mean? Do we accept consciousness as a brute fact, as unexplainable as the existence of matter itself? Do we redefine our theories of reality to include it as fundamental? Or do we double down on the search for neural correlate, trusting that explanation will come? For now, the mainstream remains pragmatic. Researchers continue charting the neural underpinning, building models like IIT and global workspace theory, because those models produce testable predictions. They fit the ethos of science: to measure, to test, to refine. But the very act of doing so highlights the divide. On one side lies the measurable machinery of the brain. On the other lies the inescapable mystery of what it feels like to be alive. And so we find ourselves at a crossroads. The scientific foundations give us a powerful map of consciousness as brain-generated, offering both clarity and utility. But they also reveal the boundary of explanation, the moment where mechanism gives way to mystery. The contrast is stark. The neural correlates of consciousness are increasingly well understood, yet the question of why they give rise to experience remains unsolved. It is here, in this space between knowledge and ignorance, that the next stage of our journey begins. Because while neuroscience charts the physical, other thinkers ask whether physics itself, especially quantum physics, might hold a clue. If matter at its deepest level behaves in ways that defy classical intuition, could consciousness be more than an emergent property? Could it be something woven into the very structure of the cosmos? That question, daring and controversial, leads us to the frontier where science meets speculation and where the mystery of consciousness begins to expand beyond neurons into the quantum fabric of reality itself. The playground of mystery. At the turn of the 20th century, physics was supposed to be finished. The great minds of the era believed that the universe was largely understood, a cosmic machine running with clockwork precision, its gears and levers described by Newton's laws and Maxwell's equations. A few loose ends remain, but the prevailing sentiment was one of triumph. Physics had mapped the heavens, explained the tides, and even hinted at the nature of light. The story seemed complete, and then the floor gave way. What emerged in the early decades of the 1900s was not a mere refinement of Newton's orderly cosmos, but a revolution that shattered its foundations. At the heart of this upheaval was quantum mechanics, a theory so strange that even its founders admitted they did not fully understand it. Niels Bohr once confessed, "Anyone who is not shocked by quantum theory has not understood it." And Albert Einstein, no stranger to revolutionary thinking himself, derided it as incomplete, famously quipping, "God does not play dice with the universe, but play dice it seemed to do." The first great shock was the principle of superposition. In the quantum world, particles like electrons and photons do not exist in definite states until they are observed. Instead, they linger in a haze of probabilities, occupying multiple possibilities at once. A particle can be here and there, spin up and spin down like a coin spinning in the air before it lands. But unlike a coin, the quantum particle does not secretly know how it will fall. Only when it is measured does it collapse into a single outcome. This collapse raised unsettling questions. What does it mean for reality to exist in superposed states? Is the world indefinite until we look at it? Does the act of observation somehow conjure reality into being? The mathematics worked, but the implications bordered on the mystical. Then came entanglement, the Einstein-Podolsky-Rosen paradox, that Einstein derisively called spooky action at a distance. When two particles interact, they can become linked in such a way that measuring one instantly determines the state of the other. no matter how far apart they are. Separate them by light years, and still, the instant you measure one, the other knows. This phenomenon has been confirmed again and again in experiments, most famously in Alain Aspect's groundbreaking tests in the 1980s. Entanglement defies our classical sense of locality. Somehow, at the quantum level, reality is woven together in a way that transcends space and time. If superposition and entanglement were not enough, quantum mechanics also introduced the observer effect. Experiments like the double-slit experiment revealed that the behavior of particles changes depending on whether they are observed. Send photons through two slits without measuring, and they form an interference pattern, as if each photon traveled both paths simultaneously, interfering with itself. But the moment you try to detect which slit it passes through, the interference vanishes. The photon behaves like a particle again, choosing one path. The unsettling implication, the mere act of measurement alters the outcome. Observation, it seemed, was not passive but participatory. The universe did not simply exist waiting to be recorded. It responded to the act of inquiry itself. To many physicists, these results did not mean that consciousness plays a role, but rather that measurement, any interaction that extracts information, forces quantum systems into definite states. Still, the language of observation and the eerie sensitivity of reality to measurement sparked a flood of philosophical questions. Could consciousness somehow be entwined with the fabric of quantum reality? The strangeness deepened with the concept of non-locality. Bell's theorem, proven in the 1960s, showed that no hidden variable theory could explain quantum predictions without invoking faster-than-light correlation. Reality itself, at the quantum scale, is non-local, meaning events separated by vast distances can still be deeply connected. The Newtonian vision of a neatly separated mechanistic universe gave way to one that was holistic, relational, and profoundly mysterious. And yet, despite its mind-bending implications, quantum mechanics work. In fact, it became the most accurate theory in the history of science. Transistors, lasers, superconductors, MRI machines, GPS satellites, quantum computers, all of them rest on quantum principle. The equations are flawless, the predictions stunningly precise, but the interpretation remains elusive. Physicists can calculate outcomes with near-perfect accuracy, yet still argue fiercely about what the theory means. Different interpretations sprouted like rival philosophies. The Copenhagen interpretation, championed by Bohr, insisted that quantum states remain indefinite until measured. Reality is not fully real until observation crystallized. The many-worlds interpretation, proposed by Hugh Everett, boldly declared that all possibilities in superposition are real, each branching into parallel universes. Every quantum event splits reality into countless copies, with every outcome realized somewhere. Then there is pilot wave theory, advanced by David Bohm, which suggests that particles are guided by hidden waves of information, restoring determinism. To the quantum dance, each interpretation preserves the mathematics but offers a radically different picture of reality. Is the universe collapsing into definite states only when measured? Is it endlessly branching into parallel worlds? Or is there a deeper hidden order, an implicate wholeness guiding all things? This interpretive openness, the fact that quantum theory is both exact and ambiguous, is what makes it the ultimate playground of mystery. It forces us to confront the possibility that reality is not what it seems, that beneath the everyday solidity of objects lies a domain where intuition fails and paradox reigns, and so, inevitably, consciousness enters the conversation. If quantum systems remain indefinite until observed, what counts as an observer? Is it enough for a detector to register a result, or must awareness itself be involved? Could it be that the act of conscious observation is the trigger that collapses the wave function? Or is that merely a projection of our own philosophical yearnings onto the equations? Mainstream physics tends to resist such notions. Most physicists argue that measurement does not require consciousness. Any physical interaction suffices. To invoke mind is, in their view, unnecessary and unscientific. Yet for decades, a minority of thinkers have suggested that perhaps consciousness is not just an emergent property of matter, but is entangled with the quantum order itself. Consider the speculation of John von Neumann and Eugene Wigner, who entertained the idea that consciousness might play a fundamental role in collapsing quantum states. Or the musings of Roger Penrose, who proposed that consciousness may arise from quantum processes within the brain's microtubules, a hypothesis known as the Orch-OR theory. While controversial, these attempts signal a deeper intuition that the riddles of quantum mechanics and the riddle of consciousness may not be separate puzzles, but two facets of the same enigma. Here the contrast sharpens. On one side, the conservative stance, quantum mechanics is strange, yes, but it remains a physical theory about particles and waves with no need to drag in human subjectivity. On the other side, the provocative suggestion, if matter itself behaved in ways that seem to defy classical logic, perhaps mind too is woven into this hidden order. Perhaps the very weirdness of quantum physics is a clue that the fabric of reality cannot be explained without reference to consciousness. Skeptics argue that this leap is unwarranted, that quantum theory's mysteries tempt us into mysticism. They remind us that nature often defies common-sense relativity, warped space and time long before consciousness was invoked. To smuggle mind into the equations, they warn, is to confuse philosophy with physics, but the allure remains for seekers of meaning. Quantum mechanics opens a door. It whispers that the universe is not a dead machine, but a living mystery, one in which the observer and the observed may be deeply entwined. The equations are clear, yet their story is unfinished. Like a symphony whose notes are written but whose melody is still debated, quantum physics plays a tune that scientists and philosophers alike struggle to interpret. And so the question lingers. If matter itself behaves mysteriously superposed, entangled, non-local, dependent on observation, could mind too be part of this hidden order? Are we merely passengers in a quantum universe, or are we participants, threads in its woven fabric? This is not a question with a settled answer, but it is the threshold where the scientific and the philosophical converge, where equations collide. With existential wonder, from this playground of mystery, we turn next to those who dared to suggest that consciousness itself might not only witness quantum reality, but emerge from it, or even shape it. The observer's paradox: do we collapse reality? If quantum mechanics is a playground of mystery, then the observer stands at its most enigmatic corner. For here, at the very edge of knowledge, the role of the observer becomes more than a technical detail. It becomes a philosophical riddle. Does the universe exist in definite states regardless of us, or do we, in some strange way, bring those states into being by observing them? The question is not idle speculation. It is woven into the very mathematics of quantum theory. The wave function, that ghostly probability cloud describing all possible outcomes of a quantum system, evolves smoothly and deterministically until measurement occurs. Then suddenly the wave function collapses and a definite outcome is realized. But what counts as a measurement? And why does collapse happen at all? The Copenhagen interpretation, born in the minds of Niels Bohr and Werner Heisenberg, became the earliest attempt to grapple with this paradox. According to Copenhagen, quantum systems remain in superposition until they are measured. Reality is not definite until observed. The act of measurement crystallizes one possibility into fact. Bohr urged us not to imagine the electron as having a definite position before we measure it. Such questions are meaningless. The theory tells us only what we can predict about observations, not what exists behind the scene. This interpretation, pragmatic and minimalist, has long dominated physics. It works, it predicts, but it leaves us with a lingering unease. If the observer collapses the wave function, then what exactly is the observer? A Geiger counter? A photographic plate? Or must it be something more, a conscious witness? Einstein, for one, rejected this view. He bristled at the idea that reality was unfinished until looked at. For him, the moon existed whether or not anyone observed it. His protests gave rise to thought experiments like the Einstein-Podolsky-Rosen paradox, designed to show that quantum theory must be incomplete. Yet experiments proved otherwise, vindicating quantum predictions. The moon may exist when we are not looking, but at the quantum scale, Bohr's insistence that measurement matters still holds sway. Dissatisfied with Copenhagen, some physicists turn to a more radical solution, the many worlds interpretation. Proposed by Hugh Everett in 1957, many worlds sidesteps collapse altogether. When a quantum system branches into possibilities, Everett argued, all outcomes occur each in its own parallel universe. Measure a particle's spin, and in one world it is up, in another down, with both realities equally real. In this picture, the observer does not collapse reality but becomes entangled with it, splitting into multiple versions across branching universes. Many worlds preserves the mathematical purity of the wave function, eliminating the mysterious collapse. But it does so at a staggering price, an infinite proliferation of universe. Every quantum event spawns a new branch. Somewhere, another you is watching this documentary under slightly different circumstances. Somewhere else, you never pressed play at all. Critics recoil at this ontological extravagance. To multiply worlds endlessly seems absurd. Yet in its elegance, many worlds has gained serious attention, especially among physicists seeking a deterministic framework. It paints a cosmos where nothing is lost, only multiplied, but in doing so it removes any special role for observation. The observer is simply one thread among countless, swept along in the branching tide. Others sought a different path. Bohmian's mechanics, or the pilot wave theory, revived determinism by suggesting that particles always have definite positions, guided by a hidden pilot wave that orchestrates their motion. In this view, the wave function is not a haze of probabilities, but a real guiding field. Measurement does not collapse reality. It merely reveals what is already there, steered by hidden order. David Bohm extended this into a vision of the implicate order, a deeper, enfolded reality from which the explicate world of appearances unfold. In Bohm's cosmic philosophy, wholeness replaces fragmentation. The observer, rather than conjuring reality, is part of a seamless web in which everything influences everything else. Though less popular in mainstream physics, Bohm's ideas resonated with those seeking a more holistic picture of reality, one that integrates the observer without granting them omnipotence. Still others, like Carlo Rovelli, have pursued relational quantum mechanics. According to this view, the properties of quantum systems are not absolute, but relational. An electron does not have a definite state in itself. It has a state only in relation to something else, another particle, a measuring device, an observer. Here, the very notion of objective properties dissolves. Reality is not built from self-existing entities, but from networks of relation. Each interpretation addresses the observer's paradox in its own way. Copenhagen makes measurement primary, but leaves observation undefined. Many worlds removes collapse, but multiplies reality beyond recognition. Bohmian mechanics restores order, but at the cost of introducing unseen pilot waves. Relational mechanics dissolves absolutes, but denies any final picture of reality. None resolves the paradox without controversy, and yet running through all of them is the same haunting question. What role does the observer truly play? For many physicists, the safe answer is this: observers are simply physical systems like any other. A measuring device suffices. Consciousness need not enter the equation. After all, quantum experiments succeed without invoking mind. Detectors and computers record results reliably. To insist that human awareness is necessary seems, to them, an unnecessary leap into mysticism. But for others, the language of observation refuses to be so easily reduced. They point out that the collapse postulate, as originally framed, invoked the notion of measurement without ever fully defining it. If measurement is just another interaction, why does it stand apart in the equations? Why is the wave function allowed to evolve smoothly until suddenly it is not? Could it be that the missing ingredient is the very thing we experience most intimately, consciousness itself? This possibility has tantalized philosophers and scientists alike. John von Neumann extended quantum theory to include the measuring device as part of the quantum system, showing that the collapse could, in principle, be pushed further and further up the chain. Ultimately, he argued, the chain must end somewhere, and that somewhere, perhaps, is the mind of the observer. Eugene Wigner echoed this sentiment, suggesting that consciousness may play a fundamental role in collapsing the wave function into definite reality. Though deeply controversial, such ideas highlight the central paradox. If the observer is just another physical system, why does observation seem to carry a special weight in quantum mechanics? If the observer is more than physical, if consciousness itself matters, then our current worldview may be incomplete. The contrast could not be sharper. On one side stands the mainstream conviction: observers are instruments, measurement is interaction, and consciousness is irrelevant. On the other stands the philosophical possibility that without consciousness the equations remain unfinished, the universe unrealized. Imagine what this would mean if observation by conscious agents collapses. Reality, then, awareness is not a latecomer in a material cosmos, but a participant in its unfolding. Consciousness would not be outside the equation, but central to it, not an emergent flicker of neurons, but a co-author of existence itself. Skeptics argue this is unnecessary mystification. They remind us that quantum mechanics functions without dragging consciousness into the mathematics. The universe worked just fine before humans. Why then should mind suddenly become the hinge of reality? For them, the observer's paradox is a technical puzzle, not a metaphysical revelation. And yet the question persists, because even if consciousness is not needed for the equation, it is still needed for the asking of the question. The very fact that there is an observer reflecting on observation raises the paradox anew. Consciousness is both inescapable and unexplained, the silent partner in every quantum experiment. So we are left with a dilemma. Either consciousness is irrelevant, and the observer's paradox is simply a quirk of measurement, or consciousness is woven into the very heart of reality in ways we do not yet understand. This is the precipice at which philosophy meets physics. If consciousness collapses reality, then the boundary between subject and object dissolves. If it does not, then we must explain why the universe cares about measurement at all. Either way, the observer refuses to be written out of the story, and so the paradox remains. Do we collapse reality, or does reality unfold regardless of us? Are we passive recorders or active participants? The answers lie tangled in equations, experiments, and existential wonder. From here, our journey turns to those who dared to push the paradox to its most radical conclusion, that perhaps consciousness is not merely a latecomer to the universe, but the foundation upon which the universe itself rests. Penrose, Hameroff, and the Orch-OR hypothesis. If the observer's paradox dares us to imagine consciousness as central to reality, then few have pursued that possibility with more audacity than the unlikely pair of a mathematical physicist and an anesthesiologist. Sir Roger Penrose, famed for his work on black holes and the foundations of physics, and Dr. Stuart Hameroff, a clinical anesthesiologist fascinated by the mysteries of awareness, joined forces to propose one of the boldest theories of mind in modern science, the orchestrated objective reduction hypothesis, Orch-OR. To understand the daring of their idea, we must begin with the problem Penrose sought to solve. In the 1980s, as artificial intelligence began to advance, many assumed that consciousness would eventually emerge from complex computation. If the brain was merely a biological computer, then building a machine with enough processing power should, in theory, give rise to awareness. But Penrose disagreed. He argued in his book, The Emperor's New Mind, that human consciousness could not be explained by algorithms alone. Something about human thought, particularly our capacity for mathematical insight, transcended computation. Penrose's intuition was radical. The mind must involve non-computable processes, events that cannot be reduced to step-by-step calculations. But where in nature could such processes be found? The answer, he believed, lay in the deepest mystery of physics, quantum mechanics. Enter Stuart Hameroff. As an anesthesiologist, Hameroff spent his career studying how chemical could turn consciousness on and off like a switch. What intrigued him most were the structures inside neurons, not just the synapses and firing circuits most neuroscientists focused on, but the cytoskeletal filaments known as microtubules. These tiny protein structures formed complex lattices inside cells, serving as scaffolding and transport highway. But to Hameroff, like more than mere plumbing, their orderly patterns and potential for resonance suggested they might process information at a level deeper than synapses. When Penrose and Hameroff met, their ideas fused into a single bold hypothesis. Consciousness, they proposed, arises from quantum processes within microtubules. These quantum events, far from being random or isolated, are orchestrated by the structure of the microtubules themselves. The objective reduction part of the theory refers to Penrose's claim that wave function collapse is not triggered by observation or measurement, but by an intrinsic physical threshold. When quantum superpositions reach a certain complexity, they spontaneously collapse into definite states. In Orch-OR, each collapse corresponds to a moment of conscious awareness. String these collapses together, orchestrated by the brain's microtubular architecture, and you get the flowing stream of consciousness. The mind, in this view, is not a passive byproduct of neural firing, but an active interplay between quantum reality and biological structure. The audacity of Orch-OR lies in its ambition. It is not merely a metaphor linking consciousness to quantum weirdness, but a specific, testable claim about where and how consciousness arises. Unlike many speculative theories, it identifies a physical substrate, microtubules, and a physical mechanism, orchestrated quantum reduction. And yet, the moment the theory was announced, controversy erupted. For mainstream neuroscientists, Orch-OR seemed like pseudoscience. Quantum coherence, they argued, is extraordinarily delicate. In laboratory conditions, maintaining coherent quantum states requires near absolute zero temperatures and careful isolation. The warm, wet, noisy environment of the brain seemed utterly inhospitable for such delicate quantum processing. How could superposition survive long enough inside neurons to matter? Critics also pointed out that no empirical evidence linked microtubules to consciousness. The brain's synaptic networks already provided robust explanations for information processing. To many, Orch-OR looked like an attempt to smuggle mysticism into neuroscience through the back door. But Hameroff and Penrose pressed on, gathering allies and pointing to suggestive findings. Studies showed that microtubules exhibited vibrational properties that might support quantum resonances. Advances in quantum biology revealed that living systems, from photosynthesis in plants to the navigation of migratory birds, seem to exploit quantum effects in environments once thought too noisy. If plants and birds could harness quantum-y coherent, why not brain? Supporters argued that Orch-OR offered something no other theory did: a direct bridge between physics and consciousness. Where mainstream models like integrated information theory mapped correlations, Orch-OR sought to explain the very origin of awareness. If true, it would mean consciousness is not just emergent computation, but a window into the fundamental fabric of reality. Still, skepticism remained fierce. Nobel laureate Max Tegmark calculated that quantum states in neurons would decohere far too quickly in femtoseconds to play any meaningful role in cognition. Hameroff and Penrose countered, suggesting that microtubule structures could shield and sustain coherence longer than expected. But the burden of proof lay heavy. Without concrete experimental verification, Orch-OR risked being dismissed as elegant speculation. And yet, there is something undeniably magnetic about the hypothesis. Part of its allure comes from its intellectual pedigree. Penrose is not a fringe thinker, but one of the most respected physicists of his generation, winner of the Nobel Prize for his work on black holes. His willingness to stake his reputation on the mystery of consciousness gave Orch-OR a gravitas few speculative theories enjoy. Hameroff, meanwhile, brought the perspective of a practicing physician who had witnessed consciousness flicker in and out under anesthesia, a humbling reminder of its fragility and depth. Together, they framed Orch-OR as a daring answer to the hard problem. If classical physics and computation cannot account for subjective experience, then perhaps consciousness emerges where physics itself meets its deepest uncertainty, the collapse of the quantum wave function. Here, in the quantum trembling of microtubules, mind and matter may intertwine. The contrast is stark. On one side, mainstream neuroscience insists that consciousness is brain-generated, reducible to circuits and chemistry. Orch-OR challenges this, claiming that consciousness reaches into the quantum bedrock of reality. To many, this is revolutionary, an attempt to expand science itself to include the first-person mystery. To others, it is reckless speculation dressed in scientific clothing. But even its critics concede that Orch-OR forces important questions. Could the brain be more than a biological computer? Could consciousness involve physics not yet fully understood? Are we justified in ruling out quantum processes in the brain simply because they seem improbable? After all, improbable does not mean impossible, and quantum biology has already surprised us. For those drawn to mystery, Orch-OR offers a tantalizing vision. It suggests that each flicker of awareness is not just neurons firing, but the universe itself making a choice, collapsing possibilities into actuality through orchestrated quantum events. To be conscious, then, is to participate in the unfolding of reality at its most fundamental level. For skeptics, the theory remains a castle built on sand, a beautiful story without solid foundation. Until microtubule quantum processes are directly observed, Orch-OR will remain on the fringe. And yet, the debate itself reveals something vital, that the quest to explain consciousness demands boldness, even at the risk of ridicule. Perhaps, in the end, the value of Orch-OR lies not only in whether it proves true, but in the way it expands the horizon of inquiry. It forces us to consider that consciousness may not fit neatly within the current boundaries of neuroscience or physics. It reminds us that to solve the greatest mystery of existence, we may need to venture beyond conventional wisdom into the wild territory where biology and quantum physics converge. And so the question lingers, is Orch-OR a visionary breakthrough or a misguided detour? Is it the first glimpse of a quantum mind or a mirage born of our longing to connect inner experience with cosmic law? Whatever the verdict, the hypothesis stands as one of the most daring scientific attempts to bridge mind and quantum physics. It embodies the spirit of inquiry itself, a refusal to accept the limits of current paradigm, and a willingness to risk failure in pursuit of understanding. From here, our journey widens, for even if Orch-OR falters, the idea it embodies, that consciousness may be woven into the quantum fabric of the universe, continues to inspire. Others have taken the baton, exploring panpsychism, integrated information, and cosmological theories of mind. The stage is set for an even larger question. Could consciousness be not just quantum, but cosmic? The case against quantum consciousness mystery has a certain magnetism. The strangeness of quantum physics, the allure of paradox, the dream that mind and cosmos might be bound together. These ideas draw us in, promising a story grander than the sober charts of neuroscience. But if we are to keep our inquiry credible, we must also face the case against such speculation. For as many scientists are captivated by the possibility of quantum consciousness, an equal or greater number remain unconvinced, even exasperated. Their verdict is clear. Quantum mechanics is unnecessary for explaining the mind, and invoking it risks misleading more than it illuminates. The first and most pressing objection is the problem of decoherence. Quantum coherence, the delicate state in which particles exist in superpositions, is notoriously fragile. In laboratory conditions, maintaining coherence requires extreme isolation and near absolute zero temperatures. A single disturbance from the environment can collapse a quantum state into classical behavior. The brain, by contrast, is a warm, wet, noisy environment. Neurons fire with electric pulses, Ions surge across membrane, molecules collide in chaotic cascades. To skeptics, the idea that delicate quantum states could survive, let alone orchestrate consciousness, strains credibility. Physicist Max Tegmark delivered one of the most cited critiques. In a 2000 paper, he calculated how quickly quantum states in the brain would decohere. His conclusion was devastating for quantum mind theory. Coherence in microtubules would vanish in a mere femtosecond, a million billionth of a second. Human thought, by contrast, unfolds on the scale of milliseconds. If Tegmark's numbers are right, quantum effects in the brain collapse far too quickly to influence cognition. Orch-OR and similar theories, he argued, are physically impossible. Other critics emphasize the lack of empirical evidence. Despite decades of research, no experiment has shown that microtubules sustain quantum coherence relevant to consciousness. Neuroscience has made extraordinary progress linking mental states to classical brain process patterns of neural firing, synaptic plasticity, neurotransmitter flows without ever needing to invoke quantum physics. When electrodes measure brain activity, when fMRI scans reveal networks lighting up during thought, when anesthetics silence awareness, all the evidence points to classical neurobiology at work. Anesthesiologist George Mashaw, though sympathetic to the mystery of consciousness, warns that attaching quantum labels without data risks leading science astray. He argues that until quantum effects in the brain are observed directly, claims about their role in consciousness remain speculative at best. Extraordinary claims, after all, require extraordinary evidence. Philosophers add another layer to the critique. Even if the brain somehow did harness quantum processes, would that solve the hard problem? David Chalmers himself, who coined the phrase, has argued that quantum theories of consciousness often conflate two issues. They may explain how the brain processes information, but they do not explain why information feels like. Replacing classical neurons with quantum microtubules, critics say, changes the machinery but not the fundamental mystery. Why should wave function collapse produce subjective experience any more than neuron firing does? In this view, quantum mind theories risk being a kind of mystery sandwich. They take one unsolved problem, consciousness, and insert it into another, quantum mechanics, hoping the combination yields an answer. But, as skeptics wryly note, piling mysteries together does not automatically create clarity. Neuroscientists also remind us that classical processes appear more than sufficient to explain cognition. Neural networks, even when simulated in computers, exhibit remarkable capacities for pattern recognition, memory, and learning, the very hallmarks of intelligence. While machines are not yet conscious, these successes suggest that complexity and connectivity may be enough without needing to invoke quantum effects. The brain's vast architecture, with billions of neurons and trillions of synapses, is already an engine of staggering sophistication. Why add quantum to the mix unless evidence demands it? Take anesthesia as an example. When patients lose consciousness under anesthetic drugs, brain activity shifts in measurable classical ways. Networks that normally synchronize break apart, disrupting the global integration of information. Restore the networks and awareness returns. No quantum explanation is needed, the classical account suffices. Similarly, brain injuries, strokes, and degenerative diseases alter consciousness in predictable ways based on damaged regions and circuits. Once again, the evidence points to neurons and synapses, not microtubules shimmering in quantum superposition. Even in psychology and cognitive science, classical models thrive. The global workspace theory and integrated information theory, while not complete, generate predictions that experiments can test. They frame consciousness in terms of communication, integration, and complexity concepts grounded in classical neuroscience. These models may not solve the hard problem, but they provide empirical traction. Quantum theories, by contrast, often struggle to connect with data in concrete, testable ways. There is also the matter of scientific discipline. Physicist Sean Carroll has been among the most vocal critics of quantum consciousness. He argues that invoking quantum mechanics to explain the mind is not only unnecessary, but irresponsible. Quantum mechanics, he points out, is a mathematical framework describing the behavior of particles, To leap from that to consciousness without evidence is to conflate physics with philosophy. Carroll insists that we should resist the temptation to project human mysteries into the gaps of scientific knowledge, a temptation that has, historically, led to error more often than insight. The skeptical stance is not motivated by hostility to wonder, but by commitment to rigor. Science progresses by demanding that theories earn their place, not by indulging what feels profound. To many neuroscientists, quantum mind theories resemble the vitalism of the 19th century, the belief that life required a special, irreducible, vital force. In time, biology explained life through chemistry, without invoking mystical forces. Skeptics believe consciousness, too, will ultimately be explained by classical neuroscience once the details are filled in. And yet, even as they dismantle quantum theories, most skeptics admit the problem of consciousness is far from solved. They acknowledge the hard problem's stubbornness, but their point is that adding quantum does not dissolve the mystery, it simply shifts it. Unless and until quantum effects are empirically demonstrated in the brain, the sober course is to refine classical accounts, not chase exotic speculation. The contrast here is sharp and essential. On one side stands the allure of quantum consciousness, a vision that promises to unite mind with the cosmos, to lift awareness into the heart of physics itself. On the other stands the sober demand for evidence, the insistence that extraordinary theories must rest on more than intuition and metaphor. Between them lies the tension that defines this debate, the human longing for cosmic meaning versus the scientific discipline that insists on proof. The skeptic's case, then, is not simply dismissal but a challenge. If proponents of quantum consciousness wish to be taken seriously, they must produce data, not just poetry. They must show in controlled experiments that quantum effects in microtubules or elsewhere in the brain not only exist, but play a causal role in conscious experience. Until then, the mainstream will remain unmoved. Still, one might ask, is skepticism itself too narrow? History has taught us that yesterday's impossibilities sometimes become today's discoveries. Quantum biology, once unthinkable, is now a field unto itself. The coherence in photosynthesis and bird navigation surprised many who assumed quantum effects could not survive in biological systems. Could the brain hold similar surprises? Perhaps. But skeptics remind us that possibility is not proof. The line between imagination and science is drawn by evidence, and evidence remains lacking. In this sense, the case against quantum consciousness is less a final verdict than a call for patience. It reminds us not to confuse the strange with the true or the beautiful with the real. It urges us to distinguish between what is possible, what is plausible, and what is proven, and it keeps the discourse honest, grounding soaring speculation, risk ignoring potential breakthroughs. To embrace it without evidence is to risk indulging fantasy. The wise path may lie between open to possibilities but anchored in proof. As our journey continues, we will see how some thinkers step beyond the neuroscience versus quantum debate, altogether proposing that consciousness may not be confined to brains or particles, but may be a fundamental feature of the universe itself. Panpsychism, cosmopsychism, and other daring philosophies await, each offering their own answer to the riddle. But before we leap into those horizons, the skeptic's voice must echo clearly. Consciousness is mysterious, yes, but mystery alone is not a license to bend physics to our hopes. The sober demand for evidence remains a guardrail against illusion. And perhaps in that demand lies a deeper lesson that truth, however strange, must always earn its keep. Is consciousness a field? Mapping the unseen in the history of science, some of the most profound discoveries were invisible at first. We could not see gravity, yet we felt its pull. We could not see electromagnetism, yet its sparks lit the night sky. We could not see the Higgs field, yet its presence endows matter with mass. Again and again, physics has revealed that what shapes our universe is not always visible, but fundamental fields stretching across space and time, unseen yet undeniable. What if consciousness belongs to this hidden category? The idea is as radical as it is tantalizing, that consciousness is not a late arrival, not an emergent property of neurons firing, but a fundamental field woven into the fabric of the cosmos itself. Just as the electromagnetic field governs the behavior of charged particles and the gravitational field curves the trajectories of planets and stars, perhaps there is a consciousness field that permeates reality, subtle, elusive, yet essential. The allure of this idea lies in its symmetry. Physics has taught us to search for unifying patterns beneath diverse phenomena. Forces that once seemed distinct, electricity and magnetism, for example, revealed themselves as aspects of a single field. Could consciousness too be a field awaiting recognition, a missing piece in the puzzle of existence? To see how this might be possible, we must recall what a field truly is. In physics, a field is a quantity defined at every point in space and time, exerting influence even when nothing visible is present. You cannot see Earth's gravitational field, but you know it's there when an apple falls from a tree. You cannot see an electromagnetic field, but you know it's there when a compass needle quivers toward the north. Fields are invisible architectures of reality, binding the cosmos together. The notion of a consciousness field asks us to extend this logic. If subjective experience is real, and we know it is because it is the most undeniable fact of our lives, then perhaps it has its own physical substrate, just as gravity and electromagnetism do. Consciousness may not be generated by matter, but rather matter may be a condensation, a local excitation of a deeper field of awareness. This idea is not new. Echoes of it ripple through ancient philosophy and modern speculation alike. The Vedantic sages of India spoke of chit consciousness as the ground of reality. Western philosophers such as Schopenhauer and William James flirted with the idea that mind is primary, not derivative. In the 20th century, physicists like Erwin Schrödinger and David Bohm suggested that consciousness might be woven into the cosmos, not confined to brain. Today, some theorists speak of panpsychism or cosmopsychism frameworks that imagine consciousness as ubiquitous, diffused throughout the universe. The field metaphor offers a scientific bridge for these intuitions. It allows us to imagine consciousness not as ghostly or supernatural, but as physical, albeit in a form not yet measured. Just as Maxwell's equations revealed electromagnetism and Einstein's relativity revealed gravity's curvature, perhaps future equations will describe a consciousness field. Consider the known fields of physics. The gravitational field binds planets, stars, and galaxies in their cosmic dance. The electromagnetic field governs light, electricity, and chemistry. The Higgs field, discovered through the Higgs boson in 2012, endows particles with mass, a breakthrough that confirmed the standard model of particle physics. Each of these fields was once invisible, inferred through effects before being directly measured. Might consciousness too be inferred through its effects, awareness, subjectivity, the very capacity to experience? Critics will immediately raise objection. Fields in physics are measurable, quantifiable, expressed in precise mathematics. A consciousness field, by contrast, seems vague, untestable, even mystical. How would we detect it? What would its quanta be? For electromagnetism, the photon is the carrier. For gravity, we hypothesize the graviton. What is the particle of consciousness? Skeptics argue that without testable predictions, the idea remains metaphor, not science. And yet speculation is not without precedent. Long before the Higgs boson was detected at CERN, the Higgs field was hypothesized for decades as a missing piece of physics. Dark matter and dark energy remain invisible, yet scientists take them seriously because they help explain cosmic phenomena. If vast portions of the universe's energy are invisible, is it so outrageous to consider that consciousness too might involve an unseen dimension. Some thinkers have tried to flesh out what such a field might entail. Could it have gradients or densities, stronger in brains and weaker in rocks? Could consciousness be like electromagnetism, expressed differently depending on structure and resonance? Perhaps neurons, with their intricate networks, act as amplifiers of the field, tuning into awareness the way a radio tunes into electromagnetic waves. The brain, in this vision, is not a generator, but a receiver, a biological antenna. Resonating with the consciousness field, the metaphor of reception carries intuitive weight. After all, when a radio is smashed, the music stops, but the signal still exists in the air. Likewise, when the brain is damaged, consciousness is altered, but perhaps the field itself persists, only the receiver disrupted. This perspective resonates with near-death experiences, altered states of consciousness, and other phenomena that challenge a strictly brain-bound view. Contrast sharpens the picture. The mainstream insists consciousness is emergent, arising from neurons and synapses, and no more requires a field than digestion requires one. But the speculative counterpoint whispers, perhaps we are missing something, an unseen dimension that our instruments are not yet tuned to detect. The history of science, after all, is littered with phenomena once dismissed as impossible until tools caught up. Still, the challenge remains: how would we test a consciousness field? Some suggest looking for anomalies in brain physics, unexplained coherence or correlations that resist classical explanation. Others imagine cosmological signatures. Perhaps consciousness leaves traces in the structure of reality itself. Quantum entanglement, observer effects, or even unexplained aspects of dark energy might hint at a deeper connection. But for now, these are only conjectures, sketches of possibilities not yet drawn into equations, and yet to entertain the idea is to feel the thrill of possibility. Imagine a cosmos where consciousness is not confined to fragile brains, but is woven through space-time itself, a subtle field shimmering in every corner of reality. To be alive in such a universe would mean to be an isolated spark, but a localized glow in a boundless sea of awareness. Death, in this vision, would not be extinction but dissolution back into the field, like a wave returning to the ocean. This speculative leap has profound philosophical consequences. If consciousness is a field, then it may unify subject and object, dissolving the sharp boundary between mind and world. The redness of a rose, the taste of salt, the ache of longing, all would be expressions of the field, localized and embodied, but rooted in a universal substrate. Consciousness would be less a trick of biology than the very ground of being, but speculation must be tempered with humility. Critics rightly remind us that metaphors can seduce. To call consciousness a field risks giving it the veneer of physics without its rigor. Fields in science are not poetic abstractions, but measurable realities. Without data, the consciousness field remains an idea, not a discovery. Yet history counsels patience. Invisible does not mean unreal. Magnetism was once mystical, gravity mysterious. The Higgs field was hidden for half a century before evidence emerged. Perhaps consciousness too awaits its moment of revelation. Perhaps our current tools, rooted in classical neuroscience, are blind to its subtler dimensions. Perhaps one day, a new equation, a new experiment, will make the unseen visible. Until then, the consciousness field remains a possibility, neither confirmed nor disproven, a horizon for imagination. And in that possibility lies both hope and danger. Hope, because it suggests that mind and cosmos may be more deeply intertwined than we ever dreamed. Danger, because without evidence, the line between science and mysticism grows thin. The contrast then is clear. On one side, the fields we know, gravity, electromagnetism, the Higgs tested, quantified, confirmed. On the other, the uncharted idea of a consciousness field, speculative, unmeasured, unproven. To some, it is an inspiring frontier. To others, an alluring mirage. But either way, it forces us to ask, what if the most familiar fact of our lives, our awareness, is also the most fundamental, a hidden dimension we have not yet mapped? As our journey continues, we will explore how this idea resonates with ancient philosophies, modern panpsychism, and cosmological speculation. For if consciousness is a field, then the universe itself may be alive in ways we are only beginning to imagine. From mysticism to physics, long before quantum mechanics puzzled physicists with superpositions and entanglement, long before neuroscience sought to map the neural correlates of thought, human beings were already asking the deepest question of all: what is the nature of consciousness? And in temples, monasteries, and solitary meditations, some arrived at an answer more radical than any laboratory could yet prove: that consciousness is not confined to individual minds at all. It is the cosmos itself. This vision, often called cosmic consciousness, has appeared across cultures and centuries. In the ancient traditions of India, consciousness was not a private spark flickering within brains, but the boundless foundation of all that exists. Vedanta philosophy described Brahman, the infinite, eternal reality, as pure consciousness. The individual self, or Atman, was seen not as separate, but as identical to this universal consciousness. To awaken spiritually was to recognize that one's awareness was not limited but cosmic, that the drop and the ocean were one. Buddhism, though different in its metaphysics, also challenged the notion of a bounded, isolated mind. In Mahayana, thought awareness is interdependent, part of a seamless web where no self exists apart from the whole. The idea of shunyata, or emptiness, dissolved the rigid boundaries between subject and object, suggesting that consciousness is less a possession than a shared field. To awaken was to see through the illusion of separateness. The same intuition appears in Western mysticism. Christian mystics spoke of union with the divine, where personal identity dissolves into an all-encompassing presence. The Sufi poet Rumi wrote of the drop merging into the ocean of love. The Neoplatonist philosopher Plotinus described the One, ineffable, boundless, the source of all reality, as not separate from the soul, but its deepest ground. Across cultures, mystics returned with the same message: consciousness is not in us, we are in it. For centuries, these visions remained the domain of spirituality, poetry, and philosophy. Science, by contrast, focused on matter measurable, tangible, concrete. The scientific revolution, with its triumphs of physics and chemistry, gradually pushed consciousness to the margins, reducing it to the mechanics of brain tissue. The mystical claim that all is mind seemed unverifiable, perhaps even meaningless. And yet, in the 20th and 21st centuries, science itself has begun to circle back to questions that sound uncannily familiar. In physics, quantum non-locality and entanglement suggest a universe woven together in ways that defy separateness. In neuroscience, the hard problem resists explanation, hinting that awareness may not reduce to circuitry alone. In philosophy, a resurgence of panpsychism has reopened the possibility that consciousness is not an emergent accident, but a basic feature of reality. Panpsychism, from the Greek meaning all is mind, proposes that consciousness is not confined to humans or animals, but is a universal property of matter. According to this view, even the smallest particle has some rudimentary form of experience, not thought or self-awareness, but a glimmer of subjectivity. Complex consciousness, like ours, arises from the combination and integration of these basic sparks. This idea, once considered fringe, is gaining traction among philosophers dissatisfied with both strict materialism and dualism. Thinkers like Galen Strawson, Philip Goff, and Hedda Hassel-Murch argue that panpsychism offers a middle way. It avoids the mystery of how consciousness could spring from non-conscious matter, while also avoiding the pitfalls of positing a separate, immaterial soul. If consciousness is woven into the fabric of reality from the start, the hard problem becomes less mysterious. Some scientists, too, flirt with similar notions. Physicist John Wheeler spoke of a participatory universe where observers help bring reality into being. Erwin Schrödinger, co-founder of quantum mechanics, drew on Vedanta when he suggested that there is only one mind. David Bohm's implicate order hinted at an underlying wholeness where mind and matter are. Though careful not to claim proof, these physicists acknowledged that the boundary between mysticism and science may not be as firm as once believed. And yet, a cautionary voice must also be heard. To leap from quantum entanglement to all is mine risks confusing metaphor with mechanism. Physics describes correlations between particles. It does not demonstrate cosmic awareness. Neuroscience maps brain states. It does not prove the existence of universal mind. To claim otherwise is to blur science with spirituality, an inspiring fusion perhaps, but one that risks abandoning rigor. This tension is the heart of the matter. On one side, mystical traditions proclaim with confidence, consciousness is the ground of reality, eternal and universal. On the other side, science demands restraint. Evidence must precede proclamation. Between them lies a bridge, fragile but compelling. The possibility that ancient wisdom and modern physics are converging on a deeper truth neither could claim alone. Imagine, for a moment, what cosmic consciousness would mean if taken seriously. It would mean that your awareness right now is not isolated but continuous with the awareness of all beings, of the stars and galaxies themselves. It would mean that death is not extinction but transformation, the wave returning to the ocean. It would mean that the universe itself is not a machine but a living presence, awake in ways we barely glimpse. This vision inspires, but it also unsettles. It challenges our sense of individuality, separateness of control. It forces us to reconsider ethics. If all is one consciousness, then harming another is, in some sense, harming oneself. It invites humility, reminding us that our personal dramas unfold within a mind vast beyond comprehension. But what does science actually say? Here, caution return. While panpsychism offers a philosophical framework, it remains untested. No experiment has yet shown that particles possess experience. Neuroscience continues to explain cognitive functions without invoking universal mind, and physicists, though intrigued, insist that entanglement and observer effects do not imply consciousness at cosmic scale. Still, the dialogue is valuable. Mysticism offers metaphors, visions, and experiential claims that science might one day test. Science offers discipline, skepticism, and tools that can refine or refute those visions. Together they form a conversation as old as humanity. Is reality dead matter, or is it alive with awareness? The cinematic power of this moment lies in the juxtaposition. Picture the Upanishads whispering, "Thou art that," alongside Schrödinger, suggesting a single mind. Picture Buddhist monks dissolving the self in meditation, alongside modern panpsychists arguing that mind pervades matter. Picture mystics speaking of union, alongside physicists exploring non-locality. Across centuries and cultures, the echoes converge not in certainty, but in resonance. Whether these echoes point to truth or to the poetic yearnings of the human mind remains the open question. Perhaps cosmic consciousness is real, awaiting discovery by new physics. Perhaps it is metaphor, a story humans tell to feel connected. Perhaps it is both a truth glimpsed in experience, awaiting translation into science. The contrast, then, is sharp but generative. Mysticism proclaims unity with conviction. Science counsels patience and proof. Between them lies a horizon of wonder, where ancient wisdom and modern physics stand face to face, asking the same question in different tongues. Is consciousness not just in the universe, but the universe itself? As we move forward, the journey will deepen into these frontiers, where cosmology, philosophy, and physics intertwine. For if consciousness is cosmic, then every star, every atom, every thought may be a facet of one unfathomable mind, consciousness. As the universe's code, what if the deepest truth of the universe is not matter, nor energy, nor even space and time, but information? What if reality itself is woven out of bits, the yes or no of binary logic, the pattern of distinctions that underlies everything? This provocative idea, known as it from bit, was championed by the legendary physicist John Archibald Wheeler. He argued that every physical entity, every particle, every field, every force derives its very existence from information. Reality, in this view, is not stuff, but code. Wheeler's vision was radical for its time, but it anticipated the information revolution that has since swept both science and technology. Today, from black hole physics to quantum computing, information is no longer an abstraction but a fundamental currency of the cosmos. And as this paradigm expands, a daring question emerges. If the universe is built from information, what is the role of consciousness? Could awareness itself be not an emergent illusion but the ultimate interpreter, the carrier of meaning within the informational web? To understand the weight of this possibility, we must first consider what information means in physics. Claude Shannon, the father of information theory, defined it as the reduction of uncertainty, the difference between one outcome and another. At its core, information is about distinction, this versus that, 0 versus 1. From this simple logic arises the vast complexity of communication, computation, and digital technology, but Wheeler extended the idea to the fabric of existence. It, from bit, he wrote, symbolizes the idea that every item of the physical world has at bottom a very deep bottom, in most instances an immaterial source and explanation. That what we call reality arises in the last analysis from the posing of yes-no questions. In other words, the universe exists because it is answerable, because it can be expressed in information. This vision finds resonance in modern physics, especially in the study of black hole. In the 1970s, Jacob Bekenstein and Stephen Hawking discovered that black holes are not entirely black. They radiate energy, and in doing so, they raise profound questions about the fate of information. If matter falls into a black hole, is the information it carries lost forever? Such loss would violate the laws of quantum mechanics, which insist that information is conserved. The puzzle of black hole information remains one of the great unsolved problems of physics. One resolution, championed by many, is that the information is not lost but encoded on the black hole's surface, its event horizon. This startling idea led to the holographic principle, the proposal that the entire universe may function like a hologram, with three-dimensional reality emerging from information, inscribed on two-dimensional boundaries. In this picture, the cosmos is not a stage filled with matter, but a vast computation, its reality encoded in bits at the edges of space and time. If so, then consciousness may not be a curious accident within matter, but a participant in the informational architecture of reality. Just as matter and energy are forms of information, perhaps awareness is the decoding of information into meaning. The redness of a rose, the pain of loss, the awe of a starry night, these are not mere illusion, but the universe's code rendered into lived experience. Quantum information theory strengthens this intuition. In quantum mechanics, information is not binary but qubit-based, existing in superposition and entanglement. Quantum entanglement, in fact, can be understood as correlations of information rather than spooky physical signals. When two particles are entangled, their informational states are linked across space, so that measuring one instantly specifies the other. Physics, increasingly, is written in the language of information, and so the contrast emerges. Is consciousness simply another illusion, a byproduct of information processing with no deeper significance? Or is consciousness the very heart of the process, the interpreter, without which information is meaningless? Consider a book filled with text. To the ink, molecules and paper fibers, nothing special is happening, they simply exist. But to a reader, meaning emerges. The letters are not just marks, they are carriers of thought. Information becomes experience only through interpretation. Could the universe itself be similar, its informational structure awaiting interpretation by consciousness? Without awareness, bits would remain inert. With awareness, they become reality. This possibility hints at a profound reciprocity. Information gives rise to consciousness, but consciousness gives meaning to information. The two may be inseparable, like two sides of a coin. Reality may not be it from bit alone, but it from bit through mind. Philosophers of information such as Luciano Floridi have argued that the universe can be seen as an infosphere, a vast sea of informational entities and processes. In this frame, consciousness is not outside the infosphere, but within it, a way the universe knows itself. When a conscious being looks at the stars, it is not merely processing photons into neural signals, it is the cosmos reflecting on its own code. Of course, skeptics raise serious objections. Information, they argue, is an abstract concept, a way of describing systems, not a substance in itself. To say that the universe is information may be more metaphor than physics. Moreover, even if reality is informational, why should that entail consciousness? A hard drive contains information, but it does not feel. A quantum computer manipulates qubits, but it does not dream. The leap from information to awareness is as great as the leap from matter to mind. The critics remind us that calling consciousness information risks sidestepping the hard problem rather than solving it. Just as invoking quantum mechanics does not automatically explain experience, invoking information may only reframe the mystery. Why should the processing of bits feel like anything at all? Why should informational states give rise to subjective states? The explanatory gap remains, and yet the allure is undeniable, for if reality is code, then consciousness may be the ultimate decoder. It may be that awareness is not epiphenomenal, but essential, the dimension through which the universe's informational structure comes alive. The cosmos, then, is not a lifeless machine, but a story unfolding, a story whose meaning exists only because it is read. Imagine the implications. If consciousness is tied to information, then the boundaries of mind may extend beyond biology. Perhaps artificial intelligence, if sufficiently advanced, could tap into this informational substrate, gaining not only intelligence but awareness. Perhaps the universe itself is a vast computation, with every conscious being a terminal, a node in the cosmic network. Perhaps death is not the erasure of awareness, but the reintegration of one's informational essence into the universal code. Contrast once more frames the stakes. One vision sees consciousness as illusion. The brain processes information, generating the appearance of a self, but in truth, meaning is an evolutionary trick. The other vision sees consciousness as fundamental. Without it, the informational universe would be mute, a book unread, a hologram unseen. Between illusion and fundament lies the battleground of modern philosophy and physics. John Wheeler once said, "We are participators in bringing into being not only the near and here, but the far away and long ago." To him, the universe was not a completed fact, but an unfolding question and answer dialogue with observers as participants in its creation. Whether he meant consciousness literally or metaphorically, his words capture a truth that continues to haunt science. The universe is not only strange, it is strangely tied to our capacity to know it. So we arrive at a provocative horizon. If it from bit is true, then consciousness may be the universe's code, not merely interpreting information, but co-creating reality. If false, then consciousness is still left unexplained, a mystery clinging to the edges of physics. Either way, the dialogue between mind and information refuses to fade. From here, our journey leads us further still into the cosmic and the existential. If consciousness is tied to information, then perhaps the universe itself is awake, its code humming with awareness. Or perhaps consciousness is only a fleeting local accident, a brief decoding before silence. The truth remains at the edge, an edge where physics, philosophy, and mystery meet. Experiments at the frontier speculation can inspire, but science demands testing. The history of discovery is littered with brilliant ideas that never survived the crucible of experiment. If consciousness truly stretches beyond the limits of classical neuroscience, if it is quantum, field-like, or cosmic in scope, then at some point it must leave footprints in measurable reality. And so we turn to the frontier, the laboratories, proposals and daring trials where imagination meets data. The first arena of testing lies with Orch-OR, the bold hypothesis of Penrose and Hameroff. For decades, critics dismissed it as unfalsifiable. Yet in recent years, researchers have begun probing its claims more seriously. If microtubules inside neurons really sustain quantum processes, then perhaps their vibrations can be measured. Indeed, studies by Anirban Bandyopadhyay and others have suggested that microtubules resonate at frequencies compatible with brain oscillations. These findings hint, though do not prove, that microtubules may play a more active role than conventional neuroscience assume. Hameroff points to experiments in anesthesia research, where certain anesthetic molecules bind directly to microtubules, potentially disrupting quantum coherence. If true, this would explain how anesthetics so effectively switch off consciousness. But the evidence remains preliminary and mainstream. Neuroscience still holds that anesthesia acts on synaptic receptors. The challenge is clear. Distinguishing Orch-OR's predictions from standard explanations requires extraordinary precision, the kind of measurement technology that is only now emerging. Quantum biology provides another testing ground. The discovery that quantum coherence operates in photosynthesis shocked many who assumed such effects were impossible in warm, noisy environments. Similar findings in avian navigation, where birds seem to exploit quantum entanglement to sense Earth's magnetic field, further challenged skepticism. If plants and birds can harness quantum phenomena, then perhaps neurons can too. The question is not absurd, it is empirical, but evidence for such processes in the brain remains tantalizingly out of reach. Beyond Orch-OR, researchers are exploring whether the brain exhibits quantum resonance detectable at macroscopic scales. Experiments with magnetoencephalography, MEG, and other imaging techniques search for patterns that cannot be explained classically. So far, results remain ambiguous. Neural oscillations are real and measurable, but whether they involve quantum coherence is unresolved. Critics argue that classical synchronization explains the data perfectly well. Proponents counter that subtle quantum signatures may be hidden beneath noise, awaiting more sensitive instruments. Here we encounter one of the great limits of current technology. Quantum states are notoriously fragile. Observing them without disturbing them is difficult even in carefully controlled laboratories. The brain, by contrast, is a chaotic storm of activity. To isolate and detect quantum coherence inside neurons without disrupting the very processes one wishes to measure is a monumental challenge. We may simply lack the tools, yet science pushes forward, not only in neuroscience but at the edges of physics and psychology. Consider the provocative attempts to test whether consciousness itself can influence quantum outcomes, experiments often grouped under the label of psi research. One line of inquiry revives the famous double-slit experiment. Traditionally, light or particles passing through two slits create an interference pattern, evidence of their wave-like nature. But what if conscious attention itself alters the outcome? Over the years, some researchers, including those at the Princeton Engineering Anomalies Research Peer Lab, have tested whether participants can subtly influence interference patterns by focusing intention on the apparatus. Results have been controversial. Some suggest tiny but statistically significant deviations. Others dismiss them as noise or methodological flaws. Parapsychology, more broadly, has explored phenomena like telepathy, precognition, and psychokinesis. While mainstream science remains skeptical, citing lack of replication and methodological rigor, the persistence of such studies reveals an underlying hunger to know whether consciousness can reach beyond the skull, leaving measurable traces. In the physical world, modern tools may give these questions new life. Quantum random number generators, for instance, produce unpredictable sequences based on quantum events. If human intention could bias these generators even slightly, it would suggest an interaction between mind and quantum phenomena. Some studies have claimed small effect. Most replications have found none. The debate remains unresolved, with skeptics demanding tighter controls and proponents pointing to the difficulty of measuring subtle influences. Even more speculative are proposals linking consciousness to cosmological experiment. Some physicists have asked whether cosmic-scale entanglement tests using light from distant quasars to determine measurement settings could probe whether human observation plays any role in collapse. Thus far, results align with mainstream quantum mechanics, suggesting no special role for consciousness. Still, the very act of designing such experiments shows how seriously some take the question, even if only to rule out extravagant claims. At the edge of neuroscience, researchers investigate altered states of consciousness meditation, psychedelics, near-death experiences for hints of non-classical dynamics. Some psychedelic studies show brain activity becoming less synchronized, more entropic during profound subjective experiences. Advocates suggest this could reflect tuning into a broader field of consciousness. Skeptics reply that classical explanations suffice. The gap between subjective richness and measurable data remains vast. This is the pattern at the frontier. Hints, anomalies, and possibilities, but no definitive breakthrough. Each claim encounters counterclaim. Each promising result demands replication. The allure of exotic explanations is powerful, but the sober demand for evidence remains relentless, and yet this tension itself drives progress. Without daring hypotheses, science would stagnate. Without skepticism, imagination would drift into fantasy. At the frontier of consciousness studies, both forces meet: bold speculation proposing new experiments and rigorous critique demanding they be tested to the limit. Consider the Large Hadron Collider, which confirmed the Higgs boson. Decades before its discovery, the Higgs field was dismissed by some as speculative. It became real only when experiments proved it. Advocates of a consciousness field or quantum mind hope for a similar arc, that today's bold ideas, scorned by many, may tomorrow yield measurable evidence. But for now, consciousness remains the elusive quarry, resisting every net we cast. The suspense lies precisely here. On one hand, empirical science marches on, refining brain scans, probing quantum systems, and testing parapsychological claims. On the other, the mysteries of subjective experience remain untouched, the hard problem still unyielding. We have data, yes, but not answers. We have experiments, but not proof. So what should we make of this frontier? Perhaps the lesson is humility. Consciousness may require instruments not yet invented, theories not yet imagined. The mysteries may remain unsolved, not because they are beyond science, but because science itself is still young, still evolving. Just as microbes were invisible before the microscope, perhaps consciousness's quantum field-like traces are invisible until new tools arrive. For now, the frontier is a landscape of tension. Orch-OR tests hover between promise and doubt. Brain resonance studies spark both intrigue and skepticism. Psi experiments flirt with possibility but stumble on replication. Technology limits our reach, but imagination keeps pushing outward. This contrast is stark. Empirical testing, cautious and methodical, against speculative imagination, bold and daring. Both are necessary. Without imagination, we would never seek the Higgs, never peer into black holes, never test quantum biology. Without rigor, we would drown in illusion. At the frontier of consciousness research, the dance between these forces continues a precarious balance that keeps the mystery alive. And so we stand at a threshold. Experiments probe, but mysteries remain. Data accumulates, but meaning eludes. Consciousness, the most intimate fact of our lives, still slips beyond the nets of science. Yet perhaps that is precisely what makes this journey compelling. For if the frontier were settled, the story would end. And the story of consciousness is far from over. From here, our exploration turns toward the horizon of philosophy and cosmology, toward theories that imagine consciousness not as a local quirk, but as a principle woven into the universe itself. If experiments at the frontier have yet to capture it, perhaps the answers lie not in the lab alone, but in the very structure of reality. If consciousness is a field imagined, for a moment, that consciousness is not a fleeting byproduct of neuron firing, not an accident of biology, but a field, a deep, universal presence woven into the very fabric of the cosmos. What would it mean for the nature of life, death, and everything in between? What if awareness itself were not local, not confined to the individual mind, but a fundamental force like gravity, like electromagnetism, like the very space-time that holds the stars? To ask this is to touch the edge of an existential horizon. For if consciousness is indeed a field, then it fundamentally alters our understanding of existence. It suggests a universe not of isolated minds in separate bodies, but of interconnected awareness, of vast living tapestry where every being, every particle is woven into one cosmic consciousness. The implications are as profound as they are unsettling. First, consider the most profound question of all. What happens when we die? If consciousness is a quantum field, then death is no longer the extinguishing of awareness, but its transformation. Just as energy cannot be destroyed but only transformed, perhaps awareness, the very essence of mind, is not erased by the end of the body. Imagine death not as a final curtain, but as a shift in the wave function, a dissolution of the individual self back into the broader fabric of consciousness. The separation between you and the cosmos may be an illusion, and death may simply be the shedding of one particular form of experience. The wave of awareness which once localized in a human body may return to the universal field, a return not to oblivion, but to a deeper state of being. This idea offers a kind of immortality, not as the preservation of a fixed self, but as the continuity of awareness itself. Perhaps in this vision, death is a return to the source. Like a river flowing into the ocean, the individual consciousness merges back into the universal field of awareness, no longer bound by the limitations of time, space, or form. The sense of self, that feeling of I am, does not cease. It simply dissolves its individual identity like a drop returning to the ocean and becomes part of the vast expanse of consciousness that holds all things. For those who seek meaning in life, this idea offers solace. It suggests that we are not alone, not isolated beings clinging to fleeting lives, but part of something vast and eternal. Our awareness, our consciousness, is not a random spark in the void, but a thread in the cosmic web, a part of a larger, eternal mind. In this vision, the self is an illusion, and yet the awareness that gives us life is timeless. Yet with this comfort comes a sobering thought. If consciousness is a universal field, then the individual self, the I that experiences it, feels, that loves and struggles, is not the final truth. It is a temporary configuration, a brief flicker of awareness within a vast, infinite field. To imagine ourselves as part of this universal mind is to relinquish the illusion of separateness, to dissolve the boundaries between self and other. It is to confront the possibility that our identity, the sense of me, is a transient phenomenon, a ripple on the surface of the great ocean of consciousness. This possibility strikes at the heart of the human experience. We spend our lives clinging to the idea of a stable, individual self, a me, that endures, that can choose, that can shape its own destiny. But if consciousness is a field, then what happens to the me after death? Does it vanish into the field, dissolving like a wave crashing against the shore? Or is the me merely one localized manifestation of the eternal awareness, forever flowing in and out of existence, reborn, reformed, but never truly lost? The question raises deep existential fears. For if the individual self is an illusion, then what does it mean to live? What does it mean to be you? Here we stand at a threshold. On one side lies the comfort of eternal mind, the idea that we are part of a vast, interconnected web of consciousness, timeless and boundless. On the other side lies the sobering possibility of self-dissolution, the realization that the me is not the essence of existence, but a fleeting expression of it, a ripple on the surface of a vast ocean, disappearing the moment we believe we are separate from it. This tension leads us to ethics, for if consciousness is a field, then we must reconsider the interconnectedness of all being. The idea of separate individual selves vanishes. If all awareness is part of one universal mind, then every act of harm, every instance of suffering, is not just the pain of an isolated individual, but the pain of the cosmos itself. This realization calls for a radical shift in ethics. In the traditional view, ethics are often grounded in the rights and well-being of individuals, you, me, us. But in a universe where consciousness is a field, where all minds are interconnected, ethics become a matter of harmonizing with the whole. To harm another is not merely to harm a separate person, it is to harm the whole field, to disturb the cosmic harmony. Compassion, then, is not just a moral choice, but a recognition of our interconnectedness with all beings, a recognition that every act of kindness reverberates throughout the universe, just as every act of violence does. In this view, ethical responsibility extends beyond human society. It stretches to all sentient beings, to the planet, and perhaps even to the cosmos itself. If consciousness is universal, then our thoughts, our intentions, our actions are not isolated but echo across the field, shaping the reality we all share. To live ethically is to live in alignment with the great mind that we are a part of, to recognize that the suffering of one is the suffering of all, and that the joy of one is the joy of the universe. The implications of this shift in perspective are staggering. What if our lives, our choices, are not isolated but intricately woven into the fabric? What if every thought we have, every action we take, ripples out into the cosmic field, shaping not just our lives, but the universe itself? What if, in every moment, we are not merely passive observers of reality, but active participants in the unfolding of consciousness? This vision of a universal field of consciousness also raises profound questions about cosmic purpose. If consciousness is a field, then is there a purpose to its unfolding? Is the universe aware of itself? Does it have direction, intention, or is it simply a vast, uncharted sea of mind, undirected but alive? The search for purpose has been central to human existence, but in a universe where consciousness is fundamental, the search takes on new depth. Perhaps the purpose of the cosmos is to awaken to become aware of itself, to recognize the interconnectedness of all things. If this is the case, then our lives may not be random accidents, but part of the cosmic process of self-realization. We, as conscious beings, may be the universe's means of knowing itself, the eyes through which it experiences its own existence. In this view, consciousness is not merely a product of evolution, but the driving force behind it, the universe unfolding, not just through matter, but through awareness. To see ourselves as part of this cosmic awakening is to imbue our lives with a sense of meaning and purpose that transcends the person. It suggests that our journey is not just ours, but the universe, and that every moment of awareness is a step toward deeper realization. But this vision is not without its existential weight. To recognize that we are not isolated, but part of the universal field is to confront our own impermanence. If the self is not permanent, if our identities are fleeting expressions of a greater consciousness, then we are forced to confront the fragility of our individual existence. Yet in this fragility, there is beauty. For in every moment we are part of something vast, something eternal. Our awareness is not ours alone, it is shared by the cosmos itself. And so we stand at the horizon looking out into the vastness of consciousness. If consciousness is indeed a field, then it is the field through which all life and experience emerge. It is the canvas upon which the universe paints its story. And we, as conscious beings, are both participants and witnesses to that story, a story that stretches across time, space, and beyond, touching the eternal and the infinite. The contrast is sharp. On one side, the comfort of eternal mind, the idea that we are part of something vast and timeless. On the other, the sobering possibility of self-dissolution, the recognition that the me is an illusion, a fleeting moment in the grand flow of consciousness. Both are true, both are part of the journey, for in the vastness of the field, we find both our deepest meaning and our deepest mystery. As we move forward, we will explore how these ideas resonate with both ancient wisdom and modern physics, how the truth of consciousness may be hidden in the heart of the universe, waiting for us to awaken to it. Between science and the infinite, as we reach the final moments of this journey, we stand at a precipice, not of certainty, but of wonder. We have delved into the deepest, most elusive questions about consciousness, probing the nature of mind, reality, and the cosmos itself. We have explored scientific theories, ancient philosophies, and speculative horizon, all seeking to answer the same question: what is consciousness? And yet, despite all our discoveries, we find that the mystery remains. The field of consciousness, whether as a product of neurons firing or a hidden quantum realm pervading all things, has not been solved. The hard problem of consciousness, the very heart of our subjective experience, still eludes us. We cannot yet say with complete certainty whether the mind is merely a byproduct of the brain's physical processes or if it is something much more profound, woven into the very fabric of the universe. But in that uncertainty lies something profound. The beauty of not knowing is not just a reminder of the limits of science. It is a celebration of the mystery itself. It is a humbling realization that the questions we ask, the questions that have driven us to seek understanding across millennia, are perhaps as important as the answers we hope to find. As scientists, philosophers, and seekers, we have made tremendous strides. We have mapped the brain's neural networks, unraveled the mysteries of quantum mechanics, and even proposed that consciousness might be woven into the very structure of reality itself. Yet, for all our progress, we still find ourselves faced with one simple, awe-inspiring fact. We can ask the question. This is where the true wonder lies, not in the certainty of the answer, but in the profound capacity to wonder, to ask what consciousness is, to inquire about the nature of our own awareness, to question our place in the cosmos. This is a gift. The ability to contemplate the unfathomable, to peer into the depths of the universe and wonder at its mysteries, is what makes us human. Throughout history, science has continually expanded the boundaries of the known, revealing the immense complexity of the world around us. But each answer we uncover seems to reveal more questions, more layers, more horizons waiting to be explored. We learn about the fundamental particles of matter, only to realize that we know almost nothing about the forces that govern them. We peer into the depths of consciousness, only to find that the mystery deepens with every discovery. The more we learn, the more we are reminded of the vastness of what we do not yet understand. This is the paradox of science. It is a journey of discovery, but also a journey of humility. The more we explore, the more we realize how much is still hidden, and that perhaps is where the true beauty lies. The mystery is not something to be solved, but something to be embraced. The unknown is not a void, but a space of infinite potential, a space where our minds can stretch, grow, and evolve. We began this journey with the question of whether consciousness is merely a byproduct of the brain, or if it is a fundamental aspect of reality itself. We explored the possibility that consciousness could be a quantum field, that our awareness might be connected to the very fabric of the universe. We touched on ancient philosophies that spoke of a universal mind, and we ventured into cutting-edge science that hints at consciousness as something more than the sum of its parts. But in the end, the answer is not clear, and that is okay. Perhaps the greatest quantum field of all is the question itself. The question is not just a puzzle to be solved, but a doorway to deeper understanding. Every inquiry, every search for meaning opens up new possibility. Perhaps the act of asking, of wondering, of contemplating our place in the universe that is the true essence of consciousness. As we look out into the cosmos with its billions of galaxies, stars, and unknown mysteries, we are reminded of our own smallness. We are but a brief flicker of awareness, a vast expanse of time. But we are also part of something much larger, something that transcends the boundaries of individual minds. We are connected to the cosmos, to the stars, to the earth beneath our feet. Our consciousness, whatever it may be, is a reflection of the larger reality that surrounds us. To realize that we can ask the questions we do, to contemplate the mysteries of existence with wonder, is to recognize the immense privilege of being conscious. It is a reminder that consciousness itself is not something to be taken for granted, but something to be revered not as an accident of biology, but as a gift, a mystery, and a doorway to the infinite. Whether consciousness is a product of neuron firing, a quantum field pervading the universe, something else entirely, we know this. The question of consciousness is what connects us to the cosmos. It is the thread that ties us to the stars, to the earth, to every living thing. And in asking it, we participate in the grand adventure of existence itself. As we close this chapter of our journey, we leave you with this thought, that the mystery of consciousness is not something to be solved, but something to be lived. It is a question that stretches across time, space, and reality itself, and it is one we will continue to ask, to wonder, and to explore for generations to come. Perhaps in the end, that is the true beauty of the cosmos, that it is not a puzzle to be fixed, but a story to be lived. And the most profound part of that story is the question itself. Perhaps the greatest quantum field of all is the question itself.